Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concept of derivatives. So as per the problem, you have just walked out of the front door of your home. You notice that it closes quickly at first and then closes more slowly. In fact, the model of the movement of the door is given by d at t equals 200 times t times 2 to the power negative t, where d is the number of degrees between the door frame and the door at t seconds. So let's answer the first question. Determine when the speed of the door is positive and negative. So we can start by writing the given function. Now in this function, t represents time, and we know that time cannot be negative. So the domain for this function is t can be any value greater than or equal to 0. So that's the first step. Now, in order to find the speed of the door, we have to find the derivative of this function d at t, because the derivative will represent how fast the degrees are changing with respect to time. Now, in this d function, 200 is the coefficient of the function, so we can keep it outside the brackets. Now this function is made up of two types of functions, t, which is a polynomial function, and 2 to the power negative t, which is an exponential function, and they are being multiplied. So we should use product rule to find its derivative. So as per the product rule, we should start with the derivative of the first function, and the derivative of t is 1 times the second function plus the first function times the derivative of the second function. So the derivative of this exponential function is the exponential term itself times the ln of the base, and the base is 2, times the derivative of the exponent, and the exponent is negative t, so its derivative is negative 1. Now we can simplify this expression. So in the first part, 1 times the exponential term will be equal to the exponential term. Now in the second part, multiplication by negative 1 will make the whole term negative. Now we can simplify the expression in the parentheses by factoring out 2 to the power negative t. Now we can set the derivative equal to 0 to find the t values at which the tangent is horizontal, because we have to find the critical points at which the derivative is equal to 0. Now we can solve this equation. So we get two cases. So the first case is now there is no t value that will make this exponential term equal to 0. So this case has no solution. Now we can analyze the second case. So we can move this t term to the right side, and that will make it positive. And now we can divide both sides by ln 2. So the ln 2's on the right side get cancelled out. So we get 1 over ln 2, and 1 over ln 2 can be evaluated as 1.443. So this is a critical number for this function. Now we ignored the 200 because 200 is a constant, so it won't give us any value of t for which the derivative is equal to 0. Now we have to use the first derivative test to find on which part of the t-axis is the derivative greater than 0 and less than 0, because we have to find the time when the speed of the door is positive and negative, and the speed of the door is represented by the derivative of this d function. So we can use the number line method. So we can use the critical number. So this critical number divides the t-axis into two parts. So we have to see whether the derivative is positive or negative on the left and the right side of this critical number. So we have to use test values. So on the left side, we can use the test value 1, and on the right side, we can use the test value 1.5. So we'll sub in these test values in the derivative. So we can use this equation. So let's start with t equals 1. Now we can evaluate this expression. So 200 times 2 to the power negative 1 is equal to 100. And now we can evaluate the expression in the parentheses. 1 minus 1 times ln 2 is equal to 0, 7. So I rounded the answer to 3 decimal places, and the multiplication will give us a positive value. That means the derivative is positive on the left side of the critical number. That means the speed of the door is positive on the left side of the critical number. Now we can do the analysis on the right side. So we can sub in t as 1.5. So for the first part, so 200 times 2 to the power negative 1.5, I got 70.71. Now we can evaluate the expression in the parentheses. So I got negative. I rounded the answer to 2 decimal places. So if we do this multiplication, we'll get a negative result. So that means the derivative is negative on the right side of the critical number. So now we can write the intervals when the speed of the door is positive and negative. So let's start with the positive. So now we found that the derivative is positive on the left side of this critical number, and as per the domain, the t value has its lowest value equal to 0. So that's the lowest possible value for t. So that means the interval when the speed of the door is positive is, so this is the answer in interval notation, and in the inequality notation we can write the interval as, now we can write the interval when the speed is negative. So as per our analysis, the speed is negative on the right side of the critical number. So the interval in interval notation is, and in the inequality notation we can write it as, so this should be the final answer for the first part. Now we can analyze the second part. What is the maximum opening between the door and its frame in degrees? Now the critical number that we just found represents a local maximum because the function is increasing on its left side because the first derivative is positive, and the function is decreasing on the right side of the critical number. So that's our first observation. Now we can find the maximum opening by subbing in t as 1.443 in the given d function. So now we can evaluate this expression. So 200 times 1.443 is equal to 288.6 times 2 to the power negative 1.443, which is equal to, so I rounded the answer to 4 decimal places, and now we can do this multiplication. So I got 106.15, and the unit is degrees. So this is the maximum opening between the door and its frame in degrees. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.